Now we have to get electric potential of dipole on its axis. So already we have got the formula for the electric potential at any point due to an electric dipole, and that formula is here: V is equal to P cos theta upon 4 pi epsilon naught r square. This is the formula for the potential at any point due to an electric dipole. Suppose you have got dipole like this is minus and this is plus q, and this line is joining here. This is called axis of the dipole. So now if you want to get any potential at any point here or any here, if we are taking the point this, then we can take theta equal to 0 degree, because the dipole moment is in this direction, and if we take this point here, we can take theta is equal to pi radian, that means 180 degree. So on the axis we can put theta is equal to 0 degree or pi radian, that means 0 degree or 180 degree. When we replace this value 0 or 180 degree over here, we will be getting V is equal to plus minus, plus is for 0, minus for pi radian, that we will be getting here P upon 4 pi epsilon naught r square. So this is the formula for the electric potential at any point on the axis of the dipole. So if theta is 0, that is a plus sign, if it is pi, that is a negative sign. Now we can get electric potential of dipole on equatorial line. So suppose you have taken this is a minus q and this is plus q, this is the axis of the dipole, and this perpendicular bisector of this dipole axis is known as here equatorial line. So if you are taking at any point here or here, P is in this direction, then you will be taking theta is equal to 90 degree. So if you take potential at any point on this line due to this minus q and plus q, you will be getting V is equal to 0. So the potential at any point on the equatorial line of the dipole has got 0 value, but see here electric field intensity at any point on the dipole has non-zero value.